So, name the circle. Whoop, we did that already. So what you do is you put a little circle with a dot in there, and then you name it circle D because that's the name of the center, D. Okay, so there you go. Circle D. All right, name a diameter. So a diameter is a segment. So AC. Name a semicircle. Okay, so the way you name that is with arc notation. Okay, so in arc notation, it's basically like you put like a curvy arc above it. That's really all it is. So for a semicircle, what you would do is like this would be a semicircle. You can label that A, B, C with a little curvy thingy above it. So A, B, C, so you have to either go clockwise or you could go counterclockwise. So you could do C, B, A. Okay. You could technically do AC, but usually, like in books and stuff, textbooks, they usually do semicircles with 3 letters. So it's all the letters you pass on the way. Actually, 3 letters you pass on the way. A minor arc is an arc that's less than a semicircle. So like, I don't know, BC, you want to do that little guy? So BC or CB is a minor. It's like smaller. Okay. A major is like a big arc. So that one's bigger than a semi. So I don't know, maybe I'll go counterclockwise just to be wild. I'm going to go B-A-C. Woo! B-A-C is a major arc. Whoa, that's majorly big. Okay. I don't know, just go with it. Okay. Then a central angle is an angle in the center. Groundbreaking. Okay. So center angle. Get it? Okay. So it'd be angle BDC is a central angle. It's an angle formed by 2 radii where the vertex is in the center. Fun fact, if this is 70 degrees, so is its central angle, the same. Okay. Apparently my copy got rid of all the arc symbols, but yours has them, hopefully. Like you have these little curvy thingies, but mine disappeared. So is interesting. Okay, anyway. So basically for this is like I kind of like these. They're kind of fun. We have to find angle DCX. So DCX. Oh, look at there. It's right there. 56. Okay, cool. Whenever they have these little M's, that's all degrees. Okay. So depending on the problem, they're kind of like puzzly to figure out, but it's still kind of fun. I kind of like them. YCM. Oh, YCW. Jeez. YCW. What? That's weird. Oh, it's straight. Know what a straight angle is? 180. There she is. Okay. Now we're in arc world. So now arc is you got a curve around the thing because it's got the curved marking of it over it. So YMW. Oh, look, half the circle is colored. Guess what half the circle is? 180. Half of 360. Okay. So 180 degrees. DX. Okay. DX is this little guy. Well, the central angle, yep, and the arc measure, they're exactly the same. Okay. Yep, same thing. And then YM. Ooh, this is where it gets fancy. YM. What? Okay, strategy. Do you see this is diameter, right? And then you got the rest of it. See what I'm saying? So to find YM, what you can do is you can do 180 minus 40 minus 56. Ooh. Okay. So 84. Okay. Okay, X, M, Y, X. Okay, so for this, I wasn't sure which way to go. Because I didn't know if I should go left or right. So if I can't go X, M, and then backtrack. Okay. So I have to go this way. I have to go counterclockwise for this one. So X, M, Y. That's a big one. Okay, so two ways to think about this. You could think of it as 360 without these. Okay. Or you could think of it, in my brain, what I did is I did 180 plus the 84. You know? Because I already figured out that pink part, you know? So it's up to you. You could do 360 minus these two, or you could do 180 plus the 84 you found. So what is that? 264. So don't say anything over 360. That'd be goofy. Okay. Thank you. All right. Inscribed angles. Ready? Central, same. Okay, so if this is 80, this is 80. Okay, inscribed is when the vertex is on the circle. So you see how it's still, the sides of it are still with the 80? That's an intercepted arc, it's called. Sounds fancy, but that's what it means. So it's basically the arc that's in between the two sides of the triangle, or the angle, sorry. And the relationship with that is that it's half, 100% of the time. Okay. You don't need to write this down, but the reasoning is if you were to like keep making that angle bigger and bigger, think of making it bigger and bigger, bigger and bigger, and it ends up being tangent, so it ends up being 180. But anyway, this guy, oh, so if this was 100, guess what that one is? 50, double in half. That's what you do. Central, same. Inscribed, half. Okay. All right. These are all called corollaries. So this is where if you've got, say you have angle C, and here's its arc, right? Okay, here you go. And then you got another angle kind of off over a little bit, but they still share the arc. Like it's the same arc they're talking about. It forces the two angles to be the same. Because think about it, if this was 100, wouldn't this be 50? This would be 50. It forces those two angles to be the same. So if they share the same arc, they're equal. You don't even need to know this number. You just can know they're equal because they share the same arc. Okay. This is a fancy inscribed angle. It's nothing new, but like the deal with this guy, angle G. If you notice on the circle, this is the arc between. Guess what that is? A semi, right? So it's 180. So this is fancy inscribed. It's a box. ACT is obsessed with this one for whatever reason. They really love this guy. So that one's a box. It's famous. So there you go. This one, I'll show you where it comes from, but essentially I'll just look at K and M just for simplicity's sake. So here, if you look at K, it's kind of a fat inscribed. So its arc across is like kind of big, right? It's that huge arc. Okay. Now, if you look at the angle across from it, angle M. So if you look at angle M and angle K, okay? So angle M, its inscribed arc is this other side. So, okay, so essentially the pink arc and the blue arc add up to 360, right? Because the whole thing's together. So the pink arc and the blue arc add up to 360. Well, K and M are the inscribed angles for those arcs. So if the arcs both add up to 360, the two inscribed angles add up to half that, 180. Okay, so they're supplementary. So the rule with this is that the measure of angle K plus the measure of angle M are supplementary. They add up to 180. Okay, it's because there's arcs, there's inscribed arcs intercepted arcs add up to 360. Their inscribed angles add up to 180, which is half. If you want to die, death mistake, people set them equal. It happens every year. So don't be that kid. Then it would be cool. So don't die, set them equal. Don't set them equal. All right, so I don't think we'll do all of these, but we can start like easy here. We're going to find the angle R. So again, they're like little puzzles. They're fun. So to find angle R, okay, what you do is you're like, well, there's no angle there, so that's fun. But you find the arc across, and you're like, denied. So you do some finagling to get it. So to find it, what you do is you've got most of it besides that one. So there's 360 degrees in the whole circle. Then subtract 120, subtract 140, right? And then what's that? 100, right? So the arc's 100. And then people who do the test too fast say the answer is 100 and they forget to cut it in half. Okay, so 50 degrees. If they wanted the central angle, then it would be 100. But if it's an inscribed, so the vertex is on like the other side of it, you have to cut it in half. So 50 degrees. Okay, that one's too easy. Let's do this one. Okay, why don't you do this quick? Ready, go. Wait, just kidding. I'm missing my arc measure. Okay, now do it. Okay. So angle X, cut 86 in half, 43. To find XY, double 52, 104. Okay, that's all you have to do. Okay, so double, cut in half. You just have to know which one to do. Okay. All right, number 4. Ah, terrifying. Okay, so it's not bad. So there's a bunch of algebra junk in here. Let's focus on X because I don't know, that's what I'm going to do. So if you look at the X stuff, here's 5X. Here's 7X minus 8. And they share the same arc. They share it. So if this was 40, they'd both be 20. If this was 50, they'd both be 25. But I don't know what the number is. Don't care, because I can figure it out. They're equal. So if they share the same arc, they're forced to be the same. So what you're going to do is just algebra it up. 7x minus 8. And get 4. I'm going to do the arcs last. I'll do the y's first. Okay. Now, well, actually, I have DC highlighted. Maybe I'll just do it. Whatever. I'm going to find DC. Because you see how I got it already squiggled up there on the pink? So to find DC, I can't do like a 360 thing, you know what I mean? So I'm going to look for the inscribed angle, which I just kind of found, essentially. So what I'm going to do is I'm going to double the inscribed angle across from DC, right? So I'm going to take 5x, but then plug 4 in. So the measure of the arc is what, 40 degrees for that. So find the measure of DC, plug it in its inscribed angle, double it. Okay. And then y is kind of the same, isn't it? Right? Here's the y stuff. Whee! And then here's the other y stuff. Oh, look at there. How satisfying. These guys got to be the same. Okay, so you're going to set 5y minus 3 equals to 4y plus 7. So 10. Cool. And then they want the measure of AB. So same deal, basically. you have to find the inscribed angle. So you're going to double whatever the inscribed angle is. So I'm going to plug it in. Which one's your favorite? 5y minus 3 or 4y plus 7? I'm going to do 4y plus 7. You just pick either one. Lucky you. So you're going to go 4 times 10 plus 7. Bless you. So 47 times 2 is 154, right? Degrees. 47, 154. What am I talking about? 94.
Oh,
That was embarrassing. Couldn't think of any numbers. Okay, nope. Next one. I don't want this. How do I get rid of this? Wait a sec. Sorry. That was interesting. Okay. This guy, MP. MP, what? What am I supposed to do with that? I got no arcs. Oh, wait. Strategy. See this guy? You start with the number and try to figure stuff out. A lot of the problems is just like try to find everything you can, and then hopefully you can figure it out. Okay? So like here I can double 31. So what is that? 62. And then, okay, now what? Well, look at this guy. That's a diam. Short for diameter, did you know that? Okay, so diameter, so measure of MP, you can just take 180 minus 62. Right? 118. Questions? Okay. We'll just do 2 more, we'll call it a day. Okay, now we'll do this guy. Oh, if you want to die, ready? Death. X plus 4 equals 8x minus 4. That's death. Don't do that. Okay, first of all, they don't look the same. That helps. Second of all, that's not how you do it. Ready? So this is the plan. They don't share the same arc, so I can't do the equally thing, just like the death. But I can figure out this angle. Hey, hey. Know what it is? Because look at that guy. Look at that perfect 180 action. Hey, hey, hey. So we can box that baby up. So if I can box up C, now I'm doing like old school triangle stuff. Remember this? Just add up to 180. So you have to get the box. Like you guys have done these problems like 80,000 times, but knowing what to do is definitely the hardest part for these problems. Because once it's set up, it's fine. So you're going to add up to 180. Oh, the 4's cancel. That's good. Okay, is that it? Of course not. Silly. I have to find AC. What? Okay. Do you see how AC, it's going to be a lot like the last problem? Because there's no like arc across from it. You know what I mean? So you're like, what? Well, strategy. Okay. We can figure out this arc. See it? Because you can throw the 10 into this angle. So what is that, 14? That does not look 14, but whatever, going with it. Double it, 28, right? And then you've got a 180 action again. So to find AC, you're going to go 180 minus 28. Okay, so 152. So, questions on that one? Okay, last one. Okay, gosh, all my arcs just decide to leave. It's so sad. Okay, usually people are good with the 2x and the 58 not doing this, but for the y's, don't they look the same? But they're not. This is death. Okay, don't do this. Death. Okay, don't do it. Don't do it. They're not the same. Okay, this is the one where they're supplementary. See, I did the death again. So the angles across from each other on an inscribed quadrilateral are supplementary. So to find x, these two add up to 180. So I'm going to subtract, divide, so we get x. Okay, and then we're going to do for y, it's like the same thing. Those two are supplementary, not equal. So you're going to add them up to 180 and then solve. So what do we get? 5y plus 20. All right, so wait. Oh, I gotta find that dang arc. Where do I want to write that? I'll write it over here. Measure a bad. Okay, where is bad? B-A-D. Oh, that's a huge guy. Well, I got an arc or an angle with it. It's real fat, but it's there. You see that? And I got 2x. 2x is the fat angle. Do you see it? So to find the arc, it's an inscribed angle. So guess what? I'm doubling whatever that angle is going to be. So 2 times x. So 2 times 61. And then what is that? 122. So 244. Is that right? 245. Yep. So there you go. It's on my math lab. There are some tricky ones. My advice is to just start finding all the arcs, all the angles you can.